Okay, please, Banner, Kenlu, please enter. Okay, sir. It means it's very important. Firstly, you need to know what's the no, not this one. What's the real relationship? It's very so that means it's very important, right? So firstly, from here we can see that the draping coefficient, band rigidity, they don't have the linear relationship. It seems they have the other relationship. So we need to firstly we needed to transform also like this. It looks like they have the log linear relationship. It's a curved relationship. So firstly, we needed to transform it. We will establish two variables here. One is long b, and also another is long g. Okay, so firstly, let's calculate long b. Long b is arithmetic. The function group is arithmetic. And here is long b. Okay. Next is long g. This one, okay. And here, enter the long g here. Okay. Yeah, it's numeric, right? And the measure is scale. Okay, I change it. It's not a nominal or ordinal, it's a scale. Okay, so transfer long b and long g, these two variables. Next. Then you can draw a magic scatter. Look. Now, the draping coefficient is a linear relationship. And also here, the coefficient with long g is linear relationship. Okay? Yeah, from the transformation, now they have the linear relationship. Also, the long g is more like a linear relationship, right? Okay. And also, you can check. Okay, look here. Draping coefficient, long b, 0.684, while the band rigidity, 0.553, so it's higher. After we use the long b, the coefficient the Pearson correlation is bigger than before we use the log, right? Also the log G, after we transform to log G, the Pearson correlation is 0.857, while the original shielding rigidity is 0.771, so it's also bigger. Okay, so it's also bigger. Okay, so it means we will use log B, log G to indicate, to predict draping coefficient. Use regression, linear, draping coefficient. Here, we will use log B and log G. Firstly, we will use enter first. Okay. From the ANOVA, the model is significant at 0.001 level. When we check the coefficient, still the log B is not significant. It's 0.267. But for log G, it's very significant. Okay, and for R, here is 0.872. It's more than when we use the G. Okay, so that means the model is better than former one. But here, since the log B, the coefficient is not significant, we will rebuild a new model. Here, we will use stepwise. When we use stepwise, the log B will excluded in the model, and we just leave the log G here. Okay, and the R, I told you it's 0.857, right? So here is the model. Here's the model. We can write down. The draping coefficient is 29.139 and 15.270 multiply log shielding rigidity. Or, in briefly, log G. Okay, so here is the linear model. Sorry. Also, we can draw. Here is the predicted. Here is the predicted draping coefficient. And when we draw the scatter, the predicted F value and the here is the predicted value, and here is the real value. Yeah, you can use X for here. Why use this? It's not important, okay? Now, here is the predicted draping coefficient. Here is the draping coefficient. And you can see that it's like a linear relationship. Okay? So it means the model we established is reasonable. Okay, that's the real driving coefficient we tested. And here is the predicted driving coefficient we calculate from the regression model. Okay, so this practice is a little bit complicated, right? But I just want to use this practice, yes, to let you know it's very important to draw the plot scatter first to see if they really have the linear relationship. Okay? Everybody, can you understand? That's all for today's lecture. And for today's practice, please complete the practice for the factor analysis. Okay, and also after you complete the practice, please send me your answer before next class. Okay? Thank you for watching.